In this video, I will discuss about scientific method. At the core of sciences lies a problem-solving approach called the scientific method. The scientific method is used in all sciences, including chemistry, physics, geology, and psychology. The scientists in these fields ask different questions and perform different tests. However, they use the same core approach to find answers that are logical and supported by evidence. The scientific method has 5 basic steps plus one feedback step. First, make an observation. Second, ask a question. Third, form a hypothesis or testable explanation. Fourth, make a prediction based on the hypothesis. Fifth, test the prediction. And lastly, iterate, which is to use the results to make new hypotheses or predictions. For us to further understand scientific method, let us have an example, which is entitled Failure to Toast. Let's suppose that you get 2 slices of bread, put them into the toaster, and press the button. However, your bread does not toast. So, for the observation, the toaster won't toast. Then, ask a question. Why won't my toaster toast? Next is to propose a hypothesis. A hypothesis is a potential answer to the question, one that can somehow be tested. For example, our hypothesis in this case could be that the toast didn't toast because the electrical outlet is broken. This hypothesis is not necessarily the right explanation. Instead, it's a possible explanation that we can test to see if it is likely correct or if we need to make a new hypothesis. So after proposing a hypothesis, it's time for us to make predictions. A prediction is an outcome we'd expect to see if the hypothesis is correct. In this case, we might predict that if the electrical outlet is broken, then plugging the toaster into a different outlet should fix the problem. Next is to test the predictions. To test the hypothesis, we need to make an observation or perform an experiment associated with the prediction. For instance, in this case, we would plug the toaster into a different outlet and see if it toasts. If the toaster does toast, then the hypothesis is supported, or that is likely correct. However, if the toaster doesn't toast, then the hypothesis is not supported, or that is likely wrong. The result of a test may either support or contradict a hypothesis. Results that support a hypothesis can conclusively prove that it's correct, but they do mean it's likely to be correct. On the other hand, if the results contradict a hypothesis, the hypothesis is probably not correct. Unless there was a flaw in the test, a possibility we should always consider. A contradictory result means that we can discard the hypothesis and look for a new one. And lastly is to iterate. The last step of the scientific method is to reflect on our results and use them to guide our next steps. As we can see on the left panel, my bread toast hypothesis is supported. On the right panel, my bread still won't toast hypothesis is not supported. If the hypothesis was supported, we might do additional tests to confirm it or revise it to become more specific. For instance, we might investigate why the outlet is broken. If the hypothesis was not supported, we would come up with a new hypothesis. For instance, the next hypothesis might be that there's a broken wire in the toaster. In most cases, the scientific method is an iterative process. In other words, it's a cycle rather than a straight line. The results of one go round becomes feedback that improves the next round of question asking. So that is scientific method. Thank you for watching and I hope you have learned something.